Hi, welcome back to my channel. My name is Gina. In this video, we are going to discuss what a subspace is. First of all, we are going to look at three definitions. We call a subset of W in Rn is closed under vector addition if, for all the vectors in W, the sum of them is also in W. And we call a subset of W is closed under scalar multiplication if for all the vectors in W and any scalar such that k times the vector is also in the subset. And finally, we call a non-empty subset W is a subspace if it's closed under vector addition and closed under scalar multiplication. From here we can draw two quick remarks. First, since for any vector u, 0 times the vector equals to the 0 vector, so a subspace of Rn always contains the 0 vector. Secondly, a subset that only includes the 0 vector is the 0 subspace of Rn, and Rn is also a subspace of Rn. Now let's look at four examples. We are going to determine whether the subset is a subspace. First one, the subset W, the condition is that the first and the third component is any real number, and the second component is 0. In other words, the subset is the XZ plane, because Y is always 0. So we can also rewrite the subset as XYZ, such that Y equals to 0. Now we have to check the conditions. So from the first remark, we know that a subspace always contains a 0 vector. And the other two conditions that we need to check are whether the subset is closed under vector addition and closed under scalar multiplication. So the first condition, does the subset contains a 0 vector? And the answer is yes, the 0 vector is in it. Because the 0 vector is when all the components are 0. And the condition for this subset is that the second component is 0. And A and B could be 0. They are still in R. So 0 is in it. Second condition. Is the subset closed under vector addition? Let's take two vectors in the subset. The first one, for example, A1, 0, and B1. And we add another vector in the subset, for example, A2, 0, and B2. Now we want to check whether the result of this sum is also in the subset. So this equals to A1 plus A2 for the first component. Second component is 0 plus 0, which is still 0. Third component is B1 plus B2. So is this result still in the subset? Yes, because we still satisfy the condition. The second component is still 0. So the subset is closed under vector addition. Now let's check the third condition. Is the subset closed under scalar multiplication? So let's take any scalar in R, K. Multiply with a vector in the subset. For example, A, 0, and B. Then the result is K times A, and K times 0 is still 0, then K times B. So is this resultant vector still in the subset? The answer is yes, because we still satisfy the condition that the second component is 0. So the subset is closed under scalar multiplication. So we check all three conditions. The subset contains a 0 vector, and it is closed under vector addition and scalar multiplication. So, the conclusion is that the subset A, 0, and B is a subspace of R3. Now let's look at the second example. Here the subset has three components, X, Y, and 1. All three conditions need to be met in order for this subset to be a subspace of R3. the first condition is that the subset has to contain the zero vector. However, the third component of the subset is always 1, so it does not contain the zero vector. In other words, the subset is not a subspace. Now let's look at the third example. Here the subset has 3 components. The condition is that the third component, C, is always greater than or equals to 0. Again, we are going to check all 3 conditions. First, is the zero vector in the subset? The answer is yes. The zero vector is in it. Because when we have the zero vector, we have 0, 0, 0. It satisfies the condition that the third component is greater than or equals to 0. How about the second condition? If we take 2 vectors in the subset, for example, x1, y1, and c1, plus with the second vector in the subset, for example, x2, y2, and z2. Is the resultant vector still in the subset? The resultant vector would be x1 plus x2, y1 plus y2, and c1 plus c2. We know that the first 2 vectors are in the subset, so c1 is greater than or equals to 0. c2 is also greater than or equals to 0. So c1 plus c2 will still be greater than or equals to 0. So this subset is closed under vector addition. How about the third condition? Is the vector closed under scalar multiplication? If it's closed under scalar multiplication, then if I multiply any scalar to the vector in the subset, the resultant vector should still be in the subset. How about if I multiply any vector in the subset by -1? So -1 times x, y, and z. And we know that this vector is in the subset, so z is greater than or equals to 0. The resultant vector would be -x, -y, and -c. But I know that c is greater than or equals to 0, so -c would be smaller than or equals to 0. So the resultant vector after I multiply a negative value is not in the subset. So the subset is not closed under scalar multiplication, which means the subset is not a subspace. Finally, let's look at the last example. Here the subset has also 3 components, and the condition is that the absolute of x equals to absolute of y. Again, let's check all 3 conditions. Is the zero vector in the subset? The answer is yes. When we have 0, 0, 0, we satisfy the condition. Absolute of 0 equals to absolute of 0. How about vector addition? If I take a vector in the subset, for example, 1, 1, and 0. This vector is in the subset because absolute of x, which is 1, equals to absolute of y, which is absolute of 1. And if I add this with another vector in the subset, for example, 1, -1, and 0, this vector is also in the subset because absolute of x, which is 1, also equals to absolute of -1, that is absolute of y. But what would be the resultant vector? It would be 2, 0, and 0. But absolute of 2 does not equal to absolute of 0. And the resultant vector is not in the subset. So from here we can already conclude that the subset is not a subspace. We don't even need to check the third condition. But just for your reference, this subset is closed under scalar multiplication. But since it's not closed under vector addition, so the subset is not a subspace. And that is the end of the video. Just a quick summary. In this video, we learned what a subspace is. In order for a subset to be a subspace, we need to check three conditions. First, the subset has to include a zero vector, and the subset has to be closed under vector addition and closed under scalar multiplication. If you like my videos, please like and subscribe, and I'll see you in the next video.